This is from the 2009 AP exam, version B. We're finding the area of the shaded region. Of course, this is a polar equation. Now, it's always nice to start with the easy part and feel really good about ourselves. We know it's going to be 1/2 the integral of r squared d theta. Now we need the bounds. Okay. Now I know people are always worried about the bounds, and they are the hardest part. But important not to get too worried about it. And in fact, these bounds are not going to be hard to find. Sometimes I like to just plug in values for theta to start getting a feel for where the graph starts. And by starts, I mean when theta is 0. Where are we in the graph if we plug in 0? So I'm going to do that. If I do that, if I plug in 0, 1 minus 2 times the cosine of 0 is what? Well, the cosine of 0 is 1, so this becomes 1 minus 2. That's -1. And recalling you about graphing polar coordinates, this is the 0 degree or 0 radian line, but going back 1. It's right there. So see, I just figured out that the lower bound, this graph starts right here, so that's the lower bound. It's just 0 radians. Well, now we need to figure out what this is. And of course, this is an r value of 0. It's 0 units away from the origin. Remember, that's what r measures. So I'm going to solve this. I'm going to say, well, when does that happen? 1 minus 2 cosine theta. When is that equal to 0? When is r equal to 0? Because that's what we're looking for. So I'm going to subtract 1 from both sides. I'm going to divide by -2. And now I need to recall what angle can I put into cosine to get 1/2? Well, using the hand trick or the unit circle, whatever you want to use, you find out that theta is equal to pi over 3. So really just this little bit right here from 0 to pi over 3 tracks the region S. I'm not going to type that in, but that will be the integral that gives us the area inside that shaded region.